Hello, my name is Connie Liu. I'm an undergraduate at MIT, and today we're going to be talking about phospholipid bilayers. So on the screen right here, you can see that I drew a few examples of phospholipids and then the bilayer. So first, let's focus on the phospholipid. There's three main parts that you have to know. There's the fatty acid tails, so right below here, you see two tails, and these are fatty acids. They're mostly all composed of carbons and hydrogens. Because of this, they end up being very nonpolar, and that means that the fatty acid tails are hydrophobic. So this essentially means that they're afraid of water or don't like water. Alternatively, we look at the glycerol, and the glycerol is known for being hydrophilic, so it loves water. And then same with the phosphate head right here. So the difference between a phospholipid and a regular lipid is that the phospholipid only has two fatty acid tails and then a phosphate group, whereas a regular lipid has three fatty acid tails. So the phospholipid still has three parts, so there's still 1, 2, 3. The third just goes to the phosphate instead. So that's the breakdown of what a phospholipid looks like. Let's see how they make a cell membrane now. So a cell membrane is made out of completely phospholipids, and it's known as a bilayer. And the reason for this is because there's two layers of phospholipids, and they line up like that for a very specific reason. And it has a lot to do with the fact that the fatty acid tails are hydrophobic and the heads of the phospholipids are hydrophilic. So because there are hydrophilic ends of these phospholipids, these have to be the ones facing water. So inside the cell, there's cytoplasm, which has a lot of water content, and outside the cell, it's the same. There's a lot of water. So in that case, you want to have the hydrophilic parts on the outside in order to protect the hydrophobic parts from touching water. So right in here, all of these tails are hydrophobic, and they are essentially being sandwiched in between the bread of hydrophilic parts, so these two, in order to escape having to touch the water. This also allows the cell membrane to be semi-permeable. So your cell membrane is a semi-permeable membrane, so only certain types of things can go through, and it filters out things that shouldn't. So only things that mostly are nonpolar and are small can diffuse through the cell membrane without assistance. Even water per se has to be helped in moving through the cell membrane because it is polar. And then there are membrane proteins along the cell membrane to allow for this to happen. And the one that's involved with helping water to filter in and out of the cell is called the aquaporin. This is one of the most important membrane proteins just because it does facilitate the movement of water, which is really important for life. But let's take a look at this picture again. So essentially, we're looking at a bilayer formed because the phospholipids have a hydrophilic end and a hydrophobic end. So the hydrophobic ends have to be protected and stay away from the water, and the hydrophilic ends are lining the parts that are touching the water. So in that case, it forms a bilayer.